Alright, I'm ready for the big reveal for my new RisKey Switch. I call it the RisKey Switch V2. This is very similar to the prototype I demonstrated the other day with my sound test. As you can hear, it's very clicky. This design has about 3.5 millimeters of travel, and the actuation point is actually like 0.1 millimeters. I mean, it's right away. And it's got a very, very smooth force curve that hovers right around 48 grams of force. You can make that a little bit stronger by putting a stronger magnet here, or just doing 2 of them. And I made this one to show you how it works. It's an earlier prototype, and I actually kind of cut it a little too much. So as you can see, there's a magnet in the middle here, and that's basically how it works. This magnet, and then there's one on top, and I'll explain the one on top in just a second. So there's a magnet inside the stem, just like my RisKey Switch, that goes in and out as you press the switch. But what pulls it back is this magnet that just fell out. I made this one really loose so I could take it out, and then I just had this happen. So I'll just put this little one here, try and get it off of there. I'm going to put the phone down for a second. It's a two-handed operation. There we go. And that'll work. So the way the switch works is you print it out like this, and I made this extra wide so that I could pull the magnet out. So once you've got it inside of a key switch plate, it'll be fine. You know, it's not going to fall out like that. It actually fits in permanently. There we go. And it slides right in there. And that's how it works. But you hear that? It's kind of quiet, right? So there's actually some wiggle room here, if you can. It's hard to see, but the magnet can flip down and up just a little bit, just a smidge, right? And the way that this magnet on top works is if you put a little magnet up top here, what it does is it causes the magnet to flip up and smack against the magnet when the one gets too far away. And you can see this in action if I can get this tiny little magnet on here. And this magnet is the same type that's inside the stem. So if you listen, it's a lot louder. And that also increases the actuation force just a smidge, probably like an extra 5 or 6 grams of force. But if you really want to increase the actuation force, you put a stronger magnet down here, or just a second one underneath. Just double it up and it'll go up to 68 or so. It really adds a lot more. So this is one of the earlier prototypes. And just to demonstrate how quiet it can be, I made this one. That sound that you're hearing is basically just this keycap hitting the top of this little switch tester. It's super quiet. And I'm not going to reveal how I made it that quiet just yet. That's a surprise. But it wasn't anything special. You can see I don't have any like O-rings or anything down here. It's the same basic switch. Ha 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 ha. I'll reveal that later. And then this is one that's got a standard keycap on it. It just has some sort of random cherry that I happen to have lying around. And it's got another type of magnet, just a little magnet there, and the same type of magnet here. But this one is extra clicky. This is actually the latest prototype that I've got. You can see it's nice, and the tolerances are nice and straight, and which is one problem that I was having. It wanted to, it really wanted to bend up to the side, like it wanted to do that whenever it came back up. So you ended up with these tilted keycaps. And then for reference, this is a keyl box, the same one I had in the last video. They're about the same. In fact, my switch is just a smidge louder, but they're about the same in terms of noise and the sound they make. But if we compare it to the one that I made silent, oh yeah, there's a big difference. And I would love to hear a whole bunch of these, like a full keyboard of these. I bet it would sound fantastic. I mean, listen to that. Wow. I'm very excited about this one. So there you have it. that's my new key switch mechanism. It's so super duper simple. I mean, just look at that. It's just a magnet pulling away from another magnet. And what I'm working on right now is a way to get the top layer holding that magnet in, you know, preventing it from actually touching this magnet. I'm trying to get that thinner. Because the thinner that is, the stronger the actuation force. And right now, the smallest I can get is about 0.5 millimeters without changing my nozzle size. But I think I can do better by just changing this little stem design into a two-part design where the magnet holder slides into it somehow. But that's what I'm working on right now. And I'm very excited because this thing just feels fantastic. Having the actuation point be right at the start just feels amazing. It's almost like a micro switch.